Hey students, I just thought I would check in and also go through a couple of practice here of problems. This is our homework. This is 5-4 homework. This is day 1. This is Monday's homework. We're going to go through this first row here together in case you're needing a little extra practice, all right? Because we didn't have enough examples in the notes or whatever, just maybe you need a little bit of extra practice. So what we have here is we have those 4 formulas. These are the formulas that we got in the notes, all right? And we have to figure out, we're trying to find our hydroxide ion concentration. So to do that, we look at what we know. We know we have hydronium ion, and we're looking for hydroxide. So the formula we look for, or we're going to use, is the one that involves both of those things. And the one that involves both those things is the H3O times the concentration of hydroxide is equal to 1 times 10 to the negative 4. So that's the formula we're going to use there. So I'm going to make this just a touch bigger, still keep my formula in view. We have our hydronium ion concentration times our hydroxide ion concentration is 1 times 10 to the negative 14th. This is the formula that was given to you in the notes, and we also have it written right there. Okay, we know our hydronium ion concentration is that right there, so we're going to plug that in. 1.2 times 10 to the negative 3rd times our hydroxide ion concentration is equal to 1 times 10 to the negative 14th. At this point, we need to solve for hydroxide ion concentration, and the way to do that is to divide each side by this 1.2 times 10 to the negative 3rd so we can isolate the hydroxide ion concentration. And it will now be by itself. So in our calculator, we're going to type 1 times 10 to the negative 14th divided by 1.2 times 10 to the negative 3rd. And remember, when we're typing it into our calculator, remember we're using the E button to get there, right? We have negative 3. All right. And so our answer there, let me move this over just a little bit. All right, that way we have room to put our answer. Is going to be 8.3 times 10 to the negative 12th. And our label on that is molarity. Okay, that's our first answer. Hopefully that makes sense to everybody. All right, now for the next one, we're looking for pH. So going back up top, we're going to change colors. Let's go to purple this time. We're looking for pH. So when we're looking for pH, look at this formula right here. We can use pH equals the negative log of our hydronium ion concentration because we have our hydronium ion concentration. So pH is equal to the negative log of our hydronium ion concentration. So again, we just plug that negative log of 1.2 times 10 to the negative 3rd in. And this will give us our pH. And remember, we're going to keep 2 decimals or 2 places after the decimal. So to type it in our calculator, we're going to type negative log and then 1.2. Remember to get to that E button, all right? And then negative 3 and hit equals. And our answer is going to be 2.92. 2.92. All right. Okay. Awesome. All right. Now looking at the last one there, we're finding POH. So let's go like a navy blue. POH. And again, what can we use to get there? Well, we have a couple of different choices. We could go this way and find the negative log of our hydronium ion concentration, right? We could do that. But probably the easiest one, and the one all of us are going to want to go for, is to use this very first one, pH plus POH equals 14. All right, pH plus POH equals 14. pH plus POH equals 14. And then we just have to plug in our pH right there. So we've got 2.92 plus POH equals 14. And we're going to take 14 minus 2.92 because remember to isolate, we subtract 2.92 on each side. All right, and POH will become 11.08. It's a rough square, but it helped me out. And the last thing there is to figure out, is it an acid or a base? Well, we can look at our pH to figure that one out. And our pH is less than 7, so it is an acid. All right, I hope this helps. All right, bye.